Hello and welcome to Engineers Mindset Academy. So in the previous video, we introduced the design analysis of a rivet joint. We talked about the failure considerations and gave out all the formulas to design a rivet joint. Alright, so in this video, we will continue with a question and we are going to be using all the formulas we talked about in the previous video to solve this problem on the board. So if you missed the first video or you missed the first class, do well to look at the description of this video and you will get the link to the first video and watch it for proper understanding. Alright, so let's get to the question. The question says, two plates 16mm thick are joined by a double riveted lap joint. The pitch of each row of rivets is 2 cm and the rivets are 25mm in diameter. The permissible stresses are as follows. Tearing equals 140 meganewtons per meter squared. Shearing equals 110 meganewtons per meter squared. Bearing equals 240 meganewtons per meter squared. Question says, determine the maximum tensile force permissible on the joint and calculate the efficiency of the rivets. Alright, so let's first of all get out our parameters. Let's get down our parameters. They said two plates 16mm thick are joined by a double riveted lap joint. So the first thing to consider there is the double riveted lap joint. The number of rivets is simply what? 2. Okay, so number of rivet hole n is simply equal to 2 double riveted lap joints. All right, and again they said 16mm thick, so thickness of plate, thickness of rivet T is 16mm. So we simply convert this to meters. This becomes 16 by 10 to the power of minus 3 in meters, simply dividing 16 by 1000. All right, let's continue. It says the pitch of each row of rivets is 2 cm. So pitch was given to us. Pitch of rivet P equals 2 cm. So you have to divide by 100 just to convert to grand units, meters. And if you divide 2 by 100, you simply have 0.02 in meters. All right, and the diameter and the rivets are 25mm in diameter. So diameter of rivets D is 25mm. Also convert this to meters. This becomes 25 by 10 to the power of minus 3 in meters, simply dividing 25 by 1000. I think that should give you around 2.5 by 10 to the power of minus 4, but then you can also multiply 25 by 10 to the power of minus 3. It automatically converts it to meters. Okay, let me just highlight here off. So these are our parameters. Okay, so we still continue. Now the permissible stresses are as follows. We are given the tearing stress. Okay, tearing stress was given, which is sigma T, as the tearing stress was given as 140 meganewtons per meter squared. So you have 140 meganewtons per meter squared, and this can be 140. Mega simply means by 10 to the power of 6 newtons per meter squared. That's the tearing stress. The next is the shearing stress. So we consider shearing stress was given, and that is simply tau, permissible shear stress, and it was given as 110 meganewtons per meter squared. So we have 110 meganewtons per meter squared, and this can be written also as 110 by 10 to the power of 6. Mega simply means by 10 to the power of 6 newtons per meter squared. And finally, we were given the bearing stress of 240 meganewtons per meter squared. So bearing, and I said bearing can also be called crushing stress. Okay, or crushing stress, and that's simply 240 meganewtons per meter squared. This can also be 240 by 10 to the power of 6 newtons per meter squared. All right, so we have this for these are the given parameters in the question. Now, I said the first thing to do is to make an attempt to find the strength of the joints. And to find the strength of the joint, it means we need to find or design the rivets considering the tearing strength, the shearing strength, and the crushing strength or bearing strength. So we start by designing the tearing strength. Okay. The first thing is to design the tearing strength. All right, we design the tearing strength. And what is the relationship? Tearing strength, Ft, is simply equal to the pitch minus diameter multiplied by thickness times the tearing stress. I gave this all in the very first video. I introduced it and I explained everything about this in the first video. So do well to watch the first video on design analysis of a rivet for proper understanding. Okay, so the tearing strength, Ft, is now equal to, now mind you, P minus D is the circumference of the rivet hole. We did all of this in the first video. P minus D, the pitch minus the diameter, is simply the circumference of the rivet hole. Mind you, please, if the pitch minus diameter is going to give you a negative value, then switch it the other way around. That is to say, if the pitch is lesser than the diameter, then it becomes diameter minus pitch. In all, you must not have a negative value there for the force. You must always have a positive value. So if the pitch is lesser than the diameter, then switch it over. It becomes diameter minus the pitch. So let's look through the option now. Pitch is 2 centimeter, which is 0.02. Diameter is 25 millimeter, which is 25 by 10 to the power of minus 3. And this will give us 0.025. So which means diameter is larger than the pitch. So you have to switch it around. So this simply becomes diameter 0.025 minus the pitch 0.02 to avoid negative values. All right. Now multiply by the thickness. Thickness of the plate was given as 16 by 10 to the power of minus 3 in meters. That is 16 millimeters. So you have 16 by 10 to the power of minus 3 multiplied by the tearing stress. And the tearing stress itself is given as 140 meganewtons per meter squared. So you have 140 by 10 to the power of 6. Okay, so I'm going to be multiplying all through together to obtain a single value. So do well to multiply with me as well to avoid calculation errors, but I'm multiplying everything together. All right. So everything gives me 11200 newtons for the tearing strength. All right. So design of the tearing strength simply gives us 11200 newtons. So I'm going to wipe this stage now, the second stage, and push this up a bit. Then consider the next calculation. Okay. So I'm going to be wiping the second stage now. The second design criteria to consider is the shearing strength. Okay, the shearing strength. And in the first video, I gave out the formula for the shearing strength. And I said the shearing strength. All right, the shearing strength itself, Fx, is simply given as the permissible shear stress multiplied by the number of rivet hole times pi times diameter squared all over 4, which happens to be the area. So this is the formula to calculate the permissible shearing strength or shearing force. All right, so the shearing strength, Fs, is simply given as, so we said permissible shear stress, and the shearing stress was given in the question as 110 meganewtons per meter squared. So you have 110 by 10 to the power of 6 multiplied by n. N stands for the number of rivets. So if you look through the parameters, number of rivets hole is equal to 2. So n is equal to 2. So multiply by 2 times, we have pi d squared all over 4. Pi is a constant value, 3.142 multiplied by diameter. Diameter was given to us as 0.025. Okay. So we have 0.025 all squared divided by 4. So the shearing strength is now equal to, so as usual, I'm going to punch all together at once to obtain a single value. So do well to also punch alongside with me to avoid calculation errors. All right. So that simply gives us 108,006.25 newtons. Okay, so the shearing strength is simply 108,006.25 newtons. All right, so mind you now, I'm going to be wiping the second stage and push this up a bit. All right, so take note of this. I'm wiping the second stage and I'm pushing this up a bit. All right. Okay, so the third design criteria to consider is the bearing or crushing strength. Bearing or crushing strength. The bearing or crushing strength, okay? Bearing or crushing strength. And I gave in the previous video that the formula to calculate the bearing strength is simply given as FBC, the permissible bearing or crushing stress, multiplied by the number of rivet hole, multiplied by the diameter of rivets, multiplied by the thickness of the rivets. Okay, so that means the bearing or the crushing strength is simply equal to the bearing stress, which was given to us as 240 meganewtons per meter squared. So we have 240 by 10 to the power of 6 multiplied by the number of rivets, n is equal to 2. Number of rivets was given in the equation as 2. So multiply by 2, multiply by diameter of rivet, which we converted to 0.025, multiply by the thickness of the rivet, which was given as 16 millimeter, which is 16 by 10 to the power of minus 3. So the bearing strength or the crushing strength is equal to, so I'm pointing again all together at once. All right. That simply gives us 192,000 newtons. Okay, 192,000 newtons. All right. So these are the three basic design criteria or strengths to be considered, like I told you in the first video. Now the question says we should find the maximum permissible force. Determine the maximum tensile force permissible on the joint. The maximum tensile force permissible on the joint simply means the highest of the three forces. Okay, the highest of the three forces considered or calculated so far. And if you take a look, Ft is 11,200, Fx is of course 108,006.25, and the final, which is the bearing strength, is 192,000. Okay, so comparing the three of them, I think of course 192,000 seems to be the highest permissible force. So this is the maximum permissible force. Okay, this is the maximum permissible tensile force on the joints. So 192,000 newtons, of course, is the maximum permissible force on the joints. Now, the next question says we should calculate the efficiency of the rivet. And I said to calculate the efficiency of the rivet, it is simply given us, okay, we can do that over here now. All right, so to calculate the efficiency of a rivet, efficiency, I said you simply make it of the relationship, the list of Fx, Ft, and Fb slash C all over the pitch times the thickness times the tearing stress. All right, so this is the relationship. We multiply this by 100%. That's how you calculate the efficiency of a rivet. So efficiency is equal to, so you have to compare these results, compare this result for Ft, Fx, and Fb slash C, which is the least among them, the smallest number among them, that becomes the strength of the rivet. I said that in the previous video. The strength of every rivet is the least possible value between the tearing strength, the crushing strength, and the shearing strength. So if you look at these numbers now, 11,200 is the least amongst the three. So which means the efficiency is equal to 11,200 all over the pitch was given to us as 2 centimeter, which we converted to 0.02, multiplied by the thickness of the rivet was given as 16 millimeter, which is 16 by 10 to the power of minus 3, multiplied by the tearing stress, and the tearing stress was given as 140 meganewton. So multiply by 140 by 10 to the power of 6. Okay, the whole of this times 100%. So efficiency is equal to 11,200 all over. Let's point everything at the denominator. We have 44800 multiplied by 100%, and this is equal to 11,200 divided by answer. That gives us 0.25 times 100%. So this simply implies that the efficiency of that rivet is equal to 25%. So the rivet is actually 25% efficient. All right. So guys, that's the first calculation on the design analysis of a rivet joint. As I said earlier, the rivet strength is always the least possible number between the tearing, crushing, and the shearing strengths. Okay. So forgive me, I'm choking. All right. I'm choking. I smoke around. All right, but then that's the calculation, and this is how to find your efficiency. The first question says we should find the maximum strength or maximum force on the joint, and of course, the highest number there, which is 102,000, becomes the maximum. Sorry about that. All right, guys, so that's it on this first video. In the next video, we are going to consider a case when there is no pitch given. In this case, now it was simple because we have a pitch. Now, what if a situation where we do not have a pitch? How do we solve the question? I will see you in the next video. Thanks and check. Please do well to, of course, stay connected. Tap the subscribe button and turn on your notification bell to keep getting updates when next videos drop. In the next video, of course, we're going to do a different question altogether. Thanks and stay safe.